Okay, so here's my first question. Could I use this same idea to prove that all numbers all positive integers n, have a multiple that consists of only 3's and 0's? Could I use the same idea?
Well, I think so. So then you look at the numbers that are made of all 3's and do the same thing.
Yeah. Because when you, if you have 333 and 3,333, you're subtracting at 3,000, which is only 3's and 0's.
Okay, cool.
I think, yeah.
What's another way, a totally different way, than repeating the technique that we could have, given that we knew there was ones that was only 1's and 0's, how could I know there was one that was 3's and 0's?
Multiply it by 3.
Multiply it by 3. Yeah. All right, next question. Could I use the same technique to show that every integer has a multiple that consists entirely of only 2's and 1's as digits?
Well, I'm not sure because because you really can't get 2's and 1's from these numbers.
Okay.
So I'm not sure. But I don't think so.
I don't think so either.
Actually, well, you could maybe, but if you had a number with all 2's and a number with all 1's, maybe it would work.
Or maybe you could create a dual list, 1, 2, 11, 22, 111, 222.
Interesting. Okay, so do you think it would work, or do you not think it would work?
I think it would work.
Yeah.
Okay, so you think all numbers, all positive integers, have multiples that consist entirely of 2's and 1's?
Yeah.
Well, no, it doesn't work because of the 5's and the 10's.
Ah.
You have to have 0's.
So the same technique can't work.
So you have to have
for 2's and 1's because you'd never get a multiple of 5.
Yeah, and
You'd never get a multiple of 10.
You have to have either a 0 or 5. If you had, can you prove all numbers that all positive integers have multiple that consists of only, so you have to, those two guidelines, you have to have a multiple of, you have to either have a 5 or a 0.
Yeah. Alright, third question.
Mm-hmm.
Do you think it's true in different bases? Like if I went to base 5 instead, do you think I could find that every integer has a multiple in base 5 that consists entirely of 1's and 0's?
Well, you could do that in base 2.
Base 2 would be easy.
So base 5. Well,
so you'd have 0.
So you think this technique works in base 5?
4's.
No. Well, I don't think it works because you're basically finding multiples of 5 in base 10 when you're using 1's and 0's in base 5.
Mm-hmm.
So you're looking at just multiples of 5.
Okay.
But actually, you can only use 1 or 0 of each. So could you get any number times a multiple of 5 to equal this?
Well, remind me how our technique worked.
So
what did we do?
We wrote out numbers
What were those numbers?
that were made of all 1's.
Okay.
So maybe we could do this and then translate the numbers into base 10 and then see if it worked.
Well, in base 10, so
1.
first you have 1, and then 6.
But what is that in base 5?
So
Why are you translating into base 10?
Well, to understand the numbers.
Ah.
If you don't know what the numbers are, it might not work.
Well, you know what the number is. It would be 1, 1, 1 in base 5. 1, 1, 1 in base 5.
You don't know what they are in base 10.
Right, you don't know what they are in base 10, but you know what they are in base 5. And what did we look at when we were trying, what was our other thing we were looking at when we were trying to understand those numbers?
well, if there's a repeat in remainders.
Okay, will there be?
Well, yeah, because there still will be a set number of remainders.
Yeah. They might be represented differently.
But
Like the remainders for the number 1 million are going to look different in base 5 than they do in base 10,
Yeah.
but there's still only a million of them. Okay, so what happens now?
So, I think this technique will work in base 5.
You'll eventually find a repeat. Why?
Because you still have a set number of remainders.
Okay.
And then, and it's just in base 5. There's not like, it's not really any difference between the base 10 technique.
Can we subtract the two numbers
Yeah,
in base
yeah,
5?
you can subtract in base 5.
Even if you don't know what the numbers are,
Yeah.
you can still subtract.
Yeah.
So it turns out this works in any base.
Cool.
In any base, every integer has a multiple that consists of only ones and zeros. But not, we found, of like 3s and 2s.
Or 2s and
necessarily,
5s.
or 2s and 5s. Well, maybe 2s and 5s, because remember our only other problem before was you didn't get multiples of 5.
Mm-hmm.
Maybe 2s and 5s works. Would 3s and 7s work in base 10?
Well, no, because you have the 5s problem again.
You have the 5s problem. What other problem do you have?
You have the even numbers.
You have the even numbers problem. That's interesting. This is a very cool problem. It teaches you a lot about how numbers work. All right, good work, guys.